Hello, everybody. So we will begin to work on with a different example for. This is for the AVL. Um, Actually, AVL Tree. Then we'll begin to perform the searching operation. So in searching operation, actually, it is different since we were able to talk to the we're able to talk to the what do you call this one with the insertion in the previous video. So this one, we have to work on with pertains to research operations. Suppose that we'll begin to search. This is the resulting value in the previous discussion. And suppose that you'll be able to search the key element as 195. So you just have to work on that. So begin with from the top element in the root node. So you have to make sure that you have to compare 75 is equals to 195. So since assessing that one that is no, so therefore you have to move. Since 75 is actually less than the value of 195, so you have to move right. And by moving the right, what will be the next element? That is 95. So you have to also ask 95 is it equals to 195, that is still no. And then you have to move right since 95 is actually less than the value of 195. Then by moving right, there will be 105 that we can check. 105 is it equals to 195? Still no. Since 105 is less than the value of 195, therefore we have to check into the right side. Right child will be the 195 is it equals to the 195 itself. So that is yes, and you have to make sure um, to indicate here found at index number. Not index level number what level? So since we are not dealing with the level of a tree, we are dealing actually with the level of a node. Since we are dealing with specific to 195, so since for level of a tree that is from 0, 1, 2, and 3, so therefore um, this 195 is we can find that the level. Now, suppose that we'll begin to search 200. Okay, work on that. Since, as you have mentioned, if we will begin to think that one by searching 200 is not very clear, let's prove that one. So from there, 75 is equals to 195. You have to move right since 75 is less than. After by moving right, that is 95 is it equals to no. We are searching 200. Sorry, I'm still writing 185. Must be 200 since 200 is your key element you want to search. 95 is it equals to 200. And afterwards, moving into the right position, there will be 105. So is it equals to 200? So by moving right, um, we have to move right because 105 is actually less than the value of 200. Now, by moving into the right position, there is 195 is equals to 200, so you have to still stay here. Okay. Um, so considering that the end of the 195 is the leaf node, what can we do right now? We just have to make sure to put that 200 is not is not present. Just have to make sure to put that one. Okay. So the same thing in your for example, if you'll begin to search right now, another search 35. You just have to work from the top node or root node. 75 is equals to 35. Uh, is no. Since 75 is greater than 35, you just have to move left. Moving left, there is 45. Is it equals to 35? By checking 45 that is greater than the value of 35, what can we do? We have to move left. By moving left, there is 25. So 25 is actually less than the value of 35. What can we do? We have to move right. By moving right, there will be 35. Is it equals to 35? Yes. So therefore, where can we find it? Found at level 3 still. So that's how you will begin to work on with the searching operation of the AVL Tree. I hope so that you're able to understand this implementation because this is really so simple. Thank you so much and see you in the next video for the AVL division.